White sugar looks clean, simple, almost pure, but the liquid it comes from is dark, muddy, and smells nothing like sweetness. What turns that thick brown juice into crystal clear sugar isn't just filtering. It's a chain of chemical reactions, heat control, and separation processes so precise that one small mistake can ruin an entire batch. And there's one step in the middle of this process that most people would never expect. Yet without it, sugar would never turn white. Stay with this because the transformation is far more intense than it looks. It starts in the field, but not with sweetness. Sugar doesn't begin as crystals. It begins inside plants, either sugarcane or sugar beet. Let's focus on sugarcane. Freshly harvested sugarcane is fibrous, tough, and full of juice locked inside its structure. The moment it's cut, a timer starts, because the sugar inside begins to degrade quickly. So factories move fast. The cane is washed to remove dirt, then crushed through massive rollers. Not once, multiple times. Each pass squeezes out more juice, until what remains is dry fiber called bagasse. The extracted liquid is not sweet and clean like you'd expect. It's murky, greenish-brown, full of impurities, soil particles, plant fibers, proteins, and organic compounds. This is raw juice. And right now, it's far from becoming sugar. The leftover fiber, bagasse, isn't wasted. It's often burned as fuel to power the same sugar factory, making the process partially self-sustaining. Cleaning the dirty sweetness. Now comes the first critical transformation, clarification. The raw juice is heated and treated with lime, also known as calcium hydroxide. This isn't for flavor, it's for chemistry. The lime reacts with impurities, causing them to clump together into larger particles. Then, the mixture is heated further. Why? Because heat accelerates these reactions and helps separate unwanted materials from the juice. As the impurities rise and settle, they're removed through filtration and sedimentation processes. What's left is a clearer liquid. Not white, not crystal-like, but significantly cleaner. And here's the surprising part. At this stage, the liquid still doesn't look anything like sugar. So where do those perfect white crystals actually come from? Turning liquid into concentrated syrup. The clean juice now moves into evaporators. This is where water is removed. Large vacuum chambers heat the liquid under reduced pressure. This allows water to evaporate at lower temperatures, preventing the sugar from burning. Slowly, the liquid thickens, from juice to syrup, from thin to dense. At this point, the sugar concentration increases dramatically. But it's still dissolved, still invisible. You can't see sugar yet because it hasn't formed. The moment crystals are born. Now comes one of the most fascinating stages. Crystallization. The thick syrup is transferred into vacuum pans where conditions are tightly controlled. Temperature, pressure, concentration, everything matters. Tiny seed crystals are introduced into the syrup. These act as starting points, and then sugar begins to grow. Molecules attach to these seeds, layer by layer, forming larger crystals over time. It's not instant, it's a controlled growth process. Too fast and crystals become irregular. Too slow, and production efficiency drops. Balance is everything. The size of sugar crystals can be controlled during this stage. Smaller crystals for fine sugar, larger ones for coarser varieties. But here's something to think about. If crystals are forming inside a thick syrup, how do you separate them? Separating crystals from liquid. Once crystallization reaches the desired level, the mixture, called massicate, is sent to centrifuges. These are high-speed spinning machines. As they spin, centrifugal force pushes the heavier sugar crystals outward, while the remaining liquid, molasses, is separated. This is a critical divide. Crystals on one side, thick dark molasses on the other. And here's the twist. That molasses still contains sugar, but it's too complex to extract easily in this stage, so it's often used for other products, like animal feed, fermentation, or even alcohol production. What you throw away as waste here is actually another entire industry on its own. The whitening process. Now we reach the step most people misunderstand. Sugar isn't naturally pure white. Those crystals you see right now, they're still slightly brownish. So how do they become white? They're washed, but not just with water. Hot water or steam is sprayed over the spinning crystals inside centrifuges, removing the thin layer of molasses stuck to them. This reveals a lighter color. Then, in some processes, further refining steps are used, like carbon filtration to remove remaining color compounds. And finally, you get white sugar, clean, bright, familiar. Raw sugar crystals are naturally light brown because of residual molasses, not because they're unprocessed or less refined in the early stages. Drying and cooling. Freshly separated sugar crystals still contain moisture, so they're passed through drying units where hot air removes any remaining water, then cooled, because moisture is the enemy of storage. If sugar isn't dried properly, it clumps together, or worse, spoils. Once dried, the crystals flow freely. That's the texture you recognize. Precision at massive scale. Now step back and think about this. Every stage, crushing, clarifying, evaporating, crystallizing, separating, drying, is happening continuously. Factories don't stop. Thousands of tons of sugarcane go in. Tons of sugar come out every hour. Sensors monitor temperature, pressure, flow rates, and purity levels in real time. Because even a slight shift can affect the final product. Too much heat? Sugar caramelizes? Too little control? Crystals don't form properly. This isn't just manufacturing, it's controlled chemistry at scale. Do you see sugar as a simple, everyday ingredient? Or something that's actually engineered through complex science? Not all sugar is the same. Here's where it gets interesting. Different types of sugar come from slight variations in this same process. Refined white sugar, brown sugar, powdered sugar. The difference? How much molasses is left or added back. Brown sugar, for example, often has molasses mixed back into refined white sugar to create its color and flavor. So what looks natural isn't always less processed. Powdered sugar contains a small amount of anti-caking agent, like cornstarch, to prevent clumping. The hidden complexity of sweetness. Let's go deeper. The sweetness you taste isn't just about sugar itself. It's about crystal size, surface area, and how quickly it dissolves on your tongue. Finer sugar dissolves faster. Coarser sugar lingers longer. Same ingredient, different experience. So what you feel as taste is actually influenced by physics happening in your mouth. Waste or resource? Remember the leftover materials? Bagasse, molasses. They don't go to waste. Bagasse fuels boilers. Molasses feeds other industries. Even wastewater is often treated and reused. Modern sugar factories are designed to extract value from almost everything. Because efficiency isn't optional, it's survival. Have you ever noticed the difference between brown sugar and white sugar in taste or texture while cooking? The final packaging. Once dried and sorted, sugar moves to packaging lines. Measured precisely, sealed tightly, protected from moisture. Because sugar is hygroscopic, it absorbs moisture from the air. And that changes everything. Clumping, hardening, loss of quality. So packaging isn't just about convenience, it's about preserving the structure of each crystal. A simple spoonful or something more. Now think about this. That 1 spoon of sugar in your tea started as a fibrous plant, turned into dirty juice, cleaned through chemical reactions, concentrated under vacuum, crystallized with precision, separated at high speed, dried, cooled, and packed, all before it reached your cup. And it dissolves in seconds. That's the contrast. Complex creation, instant disappearance. If sugar production became fully natural with zero chemical processing, do you think people would accept the darker color and different taste? The reality behind the white crystals. Sugar looks simple, uniform, clean, predictable. But behind that simplicity is a process full of transformations, reactions, and precision control. From muddy liquid to perfect crystals, from chaos to consistency. And once you see that journey, you realize something. That everyday things aren't simple. They're just made to look that way, because nothing is as simple as it looks. If this made you see sugar differently, there's a lot more hidden inside everyday products than you think. So stick around and subscribe, because the next time you pick something up, you might start questioning how it was really made.